lines, and today we're looking at reflections. So our key vocabulary of reflection is still an isometry, and that creates a mirror image. So we're flipping an image, and the line that's used for reflection is called your axis of reflection. As a reminder from before, isometry or rigid motion is when that shape stays the same, like the size and everything, before and after the transformation. We're going to be talking about vertical lines and horizontal lines. So just make sure you're remembering vertical lines up and down, x equals, intersects the x-axis, and a horizontal line is going from left to right. It's always y is equal to a number. And again, it's going to intersect the y-axis. So let's take a look at what it looks like. So we've got to remember how to graph our lines. So this time we have a line x is equal to 1. So I'm going to go to my x-axis. I'm going to make sure you find the origin right here, because here's your y-axis. So where x is equal to 1 is right here. And so this is going to be my axis of reflection. Now again, there's going to be a mirror image. Now if I'm doing it over a random line, there's no actual rule. I just have to actually count and move to the other side. So for example, right here, G is 2 spots away from your axis of reflection. So on the other side, 1, 2, and this is going to be my G prime. So remember, we do the little tick mark for the new one. Q is 1, 2, 3. So 1, 2, 3 over to the other side is Q prime. Now notice that L is on your axis of reflection. So that means L is actually going to stay right there. So my new L and my old L are in the same position. And now if I connect the dots, careful, you're not connecting the origin dot that I have there, then you'll see your shape. And so then we can go ahead and write out our coordinate points. So it looks like, remember to go back to your origin here. So it looks like G is at -1 and then up to 4. And L is still at the same spot. So going from the origin, it looks like we go to the +1 and then up 2. And then the coordinates of Q, going back to your origin, it looks like we're -2 and then down 1. So again, when you're pulling those points, make sure you're finding your origin again, and you should see that reflection there. Let's do one more just to make sure that we've got the idea. So again, let's make sure we understand our graph. So here's my x-axis and my y-axis. That means my origin is right here in the middle. And we're going to be reflecting over y is equal to 1. So along my y-axis, I'm going to find where y is 1. And that's going to create my axis of reflection. Now we're going to need to flip our shape. This one's going to be a little bit more tricky just because we have some points on both sides of our line of reflection. So remember to count the boxes. So let's start with G. So G looks like it's 1, 2, 3 spots away. So on the other side, 1, 2, 3 spots away. And here's our G prime, our new G. All right, let's go ahead and pull that coordinate while we're at it. Again, go back to your origin. So from the origin, it looks like we're over 3 and then down 2. All right, let's do the next point. Let's do L. So L is 1 box away from your axis of reflection. So that means on the other side should be L prime. And looking at the origin there in green, it looks like we go over 1, but we stay the same. So y would be 0 because we don't go up or down. All right, and then last but not least, let's find Q. 1, 2. So on the other side, 1, 2. And there's our Q prime. And let's grab those coordinates. Again, find your origin. It looks like we're over 2, 4. And then going up, it looks like we're up 1, 2, 3. So yeah, when you're pulling your points, make sure to go find your origin. I know for me, I normally mark it. It just makes my life a little easier. All right, so when we are reflecting over some sort of random line, there are not consistent rules. If you notice from both of these, there's not like an actual pattern to how we got these numbers because both reflections are pretty unique. So that means you have to graph them in order to figure out what the new image is. However, if we are specifically graphing over the x-axis, the y-axis, y is equal to x, and y is equal to negative x, there are consistent rules. And as long as you know the rules, you don't have to graph, and it's also helpful just to visualize what's going on. So let's make sure we recognize those lines. Make sure to pause the video and sketch these out before listening to this, okay? All right, so let's just make sure we remember our x-axis would be this line right here. Our x-axis. So if our x-axis is our axis of reflection, we are going to keep x, whatever x is the same. But for the y, we're going to do whatever the sign is of y, we're going to be doing the opposite of that. So if y was originally a negative, it's now going to be a positive, and vice versa. If our axis of reflection is the y-axis, right here, we are going to do the opposite of x and then the same y. Now, for me, I think the way I remember this is like if I'm flipping on the x-axis, I'm going to do the opposite of what I think. It's going to impact the y. If I'm flipping on the y-axis, it's going to do the opposite of what I think. It's going to reflect the x. So I just have to realize, like, just like a reflection is a mirror, the rule in this case is also kind of like a mirror. All right, let's think back to what y is equal to x is. Y is equal to x, so that would mean when x is 1, y is 1. So quite literally, when x is 1, y is 1. Here's our dot. That would mean when x is 2, y is 2. So literally 2, 2. That would mean when x is 3, y is 3. So 1, 2, 3, 1, 2, 3. Hopefully start to see, remember that this is your diagonal line that cuts through perfectly the first and the fourth quadrants. Because remember that this would be your first quadrant and this would be your third quadrant. All right, let's look at this last one. Oops, sorry, let me explain the rule. My bad. So for y is equal to x, all you're doing is switching the position of x and y. All right, last but not least, let's look at y is equal to negative x. So for example, if we said y was, again, 2, that means x would be negative 2 because it's supposed to be the opposite of that little negative sign. Let's say y was 3. X is going to be negative 3. So let's take a look at what this looks like. So let's start from our origin. If I'm saying my y is going to be 2, and then my x is negative 2, that would put me right there. And same thing here, if my y is 3 and my x is negative 3, that would put me over here. So we start to see this diagonal line, and it's pretty much the same as the other one, it's just flipped the other way. So this one would go through the second quadrant and then the fourth quadrant. Notice that this is a positive slope, while this one has a negative slope. Oops. There we go. So for this one, this rule is the thickest of the rule because you have to switch the position of x and y, and you need to do the opposite signs for both x and y. So let's just take a look at what this looks like. We're definitely going to go into each of these a lot more in depth in the future, but again, I just want to show you how it works. We're going to do a reflection over y is equal to x because that is the one that has the thickest rule. So remember, with y is equal to x, I'm going to switch the positions of x and y, and I'm going to do the opposite of both the coordinates. So we have our triangle. So that triangle has 3 points. So we've got point A, which is at 3, 2. Let's start with that one. So in order for us to do this rule, and we can do one thing at a time, we're going to need to take our X and our Y, and we are going to first need to switch the positions. So far, I'm going to do 2, 3, because that's our switch positions. Then we also need to do the opposite of X and Y. So that means if both of these are positive, now they're both going to be negative. So this is my final answer. So my A prime, which is my new coordinate point here, is -2, -3. All right, let's try it with these two other points. So B, -1, 3. So again, I need to switch the position. So that's going to be 3, -1. And then I also need to do the opposite sign. So notice that this 3 is a positive, so that means it's going to be a negative. And that -1 will become a positive 1. So that's my answer. B prime is -3, 1. And we could graph this to prove it, but hopefully you just trust me that I'm teaching you the rule correctly. C is 1, 0. A 0. So let's think. We still have to switch the position. 0, 1. And then we're supposed to do the opposite. Now, can I do the opposite of 0? Nah, 0 is just 0. But the opposite of 1 would be -1. So my C prime is 0, -1. All right, hope that makes sense. We'll talk more about this during Zoom. Hope you have a great one.